now that we have a behavior system in place and integrated with our actor classes, it's now time to begin exploring exactly what this behavior system can do. So throughout the next few videos, we're going to be exploring different behavior types and how they can be layered together to produce specific results. In this video, we're going to begin with a behavior called Gamepad behavior. It's going to allow us to influence an actor using the Gamepad controller. So, let's get started by moving over to the behavior class, or rather the behavior code file, and we will create a new behavior class. We'll jump in here right below our behavior constant, and we'll define a new class. This will be class behavior Gamepad. Now this behavior is of course going to need to extend behavior. Then we can block in the method body. Now, this specific behavior class is going to utilize input from the Gamepad device. Now, in order to gain access, or rather easier access to those types, let's add an additional using statement to our code. Where previously we only had the types from XNA.framework, let's also look into XNA.framework.input. This will of course give us access to things like Gamepad, GameState, and so forth. Alright, so inside of Gamepad behavior, we don't need to worry about any form of state on our own here, since the Gamepad itself is going to allow us to look into the Gamepad state at any given moment, so we don't have to worry about storing that ourselves. Now, we do need to specify a constructor, since inside of our behavior class, we are requiring that the constructor specify a weight parameter, and of course inside of Gamepad, we still want to specify what weight the Gamepad behavior carries. So we're going to define a public constructor. So that will be public behavior Gamepad, and we're going to need to take in a weight. So we'll specify a float parameter of, called weight, float weight. Then we'll make sure we chain this to the base constructor, passing along the weight parameter. We're not going to worry about any kind of additional details inside of the constructor, so we'll drop some empty braces off to the right. Alright, now what we are interested in is what happens when the Gamepad behavior gets updated. So we'll provide an override to the update method. We are again not worried about any of the functionality in the base class, so we'll wipe out our call to base.update. What we are interested in doing is looking at the controller and getting the current Gamepad state, because what we want to do is read the direction from one of the analog sticks and simply read, or rather apply, that direction to the actor in question. Now, in order to look at that analog stick, we need to get a Gamepad state. So we'll make a local variable here of type Gamepad state. We'll call this variable simply pad state, and then we'll set it using Gamepad, a Gamepad class, and then we'll invoke the getState method. Now here for the player index, we're going to hard code this to a player index of 1, simply because we currently have one controller applied. And the focus of this demo isn't so much on input management, we're focusing on behavior. So for our purposes, we have one controller, and we will grab that controller's state. Alright, now that we have the controller state, we can look at interesting things like the position of the thumbsticks. And since the thumbsticks themselves are vector 2s, we can apply those in line to our actor's direction. Now, we don't want to worry about modifying the actor's direction unless we have some measurable amount of input. So we'll begin with a check. This check is going to be an if statement. That's going to look at pad state. And it's going to look into the pad state struct. It's going to grab the thumbsticks element. Out of thumbsticks, we're going to grab, more specifically, the left thumbstick. And there you can even see that left is represented here as a vector 2. So thumbsticks.left is the value that we're interested in. Now, left being a vector 2 is going to carry a length method. So we will run that method. We'll see if the resulting length is greater than 0. If so, then we have some amount of input being applied, and so we will apply the value in thumbsticks.left to the actor. That means we need to look at the actor being passed into update. We need to modify its direction. So we'll say that the actor's direction will be increased by pad state dot thumbsticks dot left. Now, just a quick note on the thumbstick orientation. Since we have a scenario where pressing up on the thumbstick is going to result in a positive reading here, and we're drawing a screen where positive Y moves down, we have kind of the opposite going on. In order to make the up action visually look like up on the screen, we need to invert the input coming in on the thumbstick. So what we'll do in order to invert Y is we'll multiply this value against a specific vector. So basically we'll assemble a vector with a negative Y value and then multiply that. So we'll take thumbsticks.left multiplied by a new vector 2. And for the x component, we'll specify 1 and thereby leave the x component alone. We won't modify it. Now for the y component, we'll multiply by negative 1, and that will allow us to invert it. So now that we've got a vector that has been inverted in y, we need to apply that, but we need to make sure we take the weight into account. We'll do that by taking the resulting vector times this, meaning this behavior instance, dot weight. That way the weight specified will control just how much of the controller's input is actually applied to the given actor. Alright, with this class in place, it's now time to jump into our game and test it out. So inside of game, or rather what I mean is the game code. Obviously we try and build now, we haven't applied it yet, so in order to see it in action, we need to add it to the current actor's behavior list. So we'll do that by jumping down here. We'll add this in addition to the constant behavior. So we'll say leader.behaviorList.add. We'll create a new instance of behavior Gamepad. So looking through a behavior list, there's behavior Gamepad. The only parameter to behavior Gamepad is weight. We'll specify a weight of 0.5. Then we can close off the parenthesis for constructing the weight. Actually, before we do that, let's make sure we specify this as 0.5f. Specify this as a float rather than a double. Alright, closing off the parenthesis takes care of the new behavior. An additional closing parenthesis takes care of the add method, and we should be ready to test. Now you will note that the behavior Gamepad has a significantly higher weight than the constant. As a matter of fact, it has 5 times the weight. That means that we can very easily override the input being given by the behavior constant. Now, to test this out, let's build and run the game. You can see that our actor starts off, makes his half a circle turn, and then continues to move to the right. Now, if we take the gamepad and begin moving the left thumbstick, we can drive our actor around the screen by simply pointing him in the direction we'd like to go. Now, even though it's fast, we can see that there is still an effect over time being applied. If we snap the control stick very quickly left and right, there are a few frames of what looks like animation. A few frames of time have to pass for the effect to go fully into place. Now, depending on the frames which get captured in this recording, that may look a little bit snappier, but when you're testing this out, you can see that making very quick moves on the controller still results in time passing inside of the game. Now, of course, we are still blending between gamepad input and constant input, so that means if we let go of the control stick, then our actor tends towards moving the positive X. So if we start moving up and then let go of the control screen, then he always wants to move off to the right. Now, one other thing that's interesting about this method of influencing the vectors is if we're moving almost directly to the left. Actually, let me give just a little bit offset there. So a little bit down. If you manage to lock directly to the left, then the actor will take a very long time to finally swing back around to the right. Now, this one artifact will cause some interesting things a little bit farther down the road. I just wanted to point that out, that since you have a scenario where it's pointing directly in one direction, so basically what's happening is constant is obviously trying to move us to the right, and if we're moving directly to the left, what we're doing is we're subtracting from that X value and then renormalizing. So it's like we're taking away only very little pieces of that value before we finally move it over. But just wanting to point that out. But aside from that, we now have the ability to demonstrate layered input inside of our behaviors. So with that, again, we're simply taking two different behaviors, assigning different weights, and then everything else is applied by simply calculating the behaviors individually, normalizing their result, and applying that to the actor itself. So with this in place, that's going to take care of this video.